Good afternoon, everyone. My name is Patrick Maléjac. I am the Secretary General of PIARC, the World Road Association, and I would like to wish you a very, very warm welcome to our webinar on smart roads classification, which we organize with the Universitat Politècnica de València in Spain, UPV. So very welcome. Our agenda is going to be quite packed, as you can see. Our colleague Alfredo Garcia from UPV will present it more in depth a bit later. It's expected to last about 2 hours with 2 sessions of questions and answers between panelists and the audience. Basic rules for some of our online meetings. So the webinar is being recorded. I hope this is fine with everyone. If you are not fine with this, I suggest you send me a message in the chat or even consider leaving the meeting. In order to organize the meeting in a way that would not lead to overload, please mute yourself and keep the video off during the presentations. This is meant to avoid background noises and connection overload for some. Use the chat feature in Zoom at the bottom right of the menu bar and ask questions at any time. This is really welcome, and I will collect them during the Q&A part and will direct them to the panelists. This is really part of why we're here. We're here to talk, we're here to chat, so please engage as much as possible. As you can see on the right side of the screen, please make sure that your name is understandable in Zoom. That's because sometimes we use nicknames or similar, and it's good to know who everyone is talking with. Basically, that's it. The introduction is expected to last for about 20 minutes, and I will go first. Again, Patrick Maléjac here, speaking on behalf of PIARC. We are the new name of the World Road Association, founded more than 110 years ago as a non-profit, non-political association. Our goal is to organize exchange of knowledge on all the topics that are related to road and road transport. ITS, obviously, road safety, transport economics, pavements, tunnels, resilience of roads and road system. We cover all that through committees that are made of experts that are seconded or nominated by member governments. We actually have 124 member governments as lead members, as well as regions, groups, companies, universities, and individuals. Our ambition is to be the first forum for the exchange of knowledge, policy on all the factors related to roads and road transport. All our reports and other knowledge products are available from our website at piarc.org. Feel free to ask questions. I'm sure the questions today will be much more focused on smart roads classification. I hand it over now to Oscar Gutierrez Bolivar from Spain, who is the chair of this project on the PIARC side. Oscar, please.
Welcome on behalf of the supervision team to all of you. I would like to introduce the members of the team. They are Patrick Maléjac, a secretary that you have been presented before, Ali Matmina from the UK, and Luz Ortega from Spain, Frédéric Champagne from Canada, Denis Cornet from Belgium, Lorenzo Domenichini from Italy, Lucy Wickman from UK, Miguel Caso, technical director of PIARC, Antonio Moraes from Spain, Sylvain Belloc from France, and Vicente Sebastián Alapont from Spain. This is a the team that is working very hard in this committee. Next slide, please. Our objective is that we need your feedback from all the world, all the stakeholders. We like to know which are your approaches for this issue, which are your challenges or opportunities that you have identified. And this is very important for us is how do you rate or how do the level of agreement or about the criteria and principles that we are going to show you. Your feedback will help us to adapt our work to your conditions, to your needs, and identify all the challenges or opportunities that arise in this webinar. Next one, please. Okay, I think it's the time for Alfredo to introduce themselves.
Okay, good afternoon, everybody. I'm Alfredo Garcia. I'm professor of highway engineering at Universitat Politècnica de València in Spain, and you are all welcome to this webinar. This PIARC special project, as Oscar has explained, aims to study and explore the feasibility of both a new framework for smart road classification and its applicability. The ultimate goal is to establish various levels of smart roads with attributes they should have in order to be able to inform user and connecting automatic vehicle of the smart level of the road segment they will be driving on, and thus they could adapt their evolution to this condition. In this webinar, we are very diverse experts working for the majority of stakeholders, which is good for gathering many feedbacks and ideas. In addition, we come from many countries around the world with very different needs, constraints, and ambition. This special project is being developed by a UPV team made up by me and Javier Camacho, associate professor, and David Llopis, assistant professor, all of us experts in highway engineering, and Jose Monserrat, professor of telecommunication and a connectivity expert. Finally, we would like to acknowledge PIARC for promoting and funding this special project and for trusting us to develop it. Thank you, Patrick, also to the PUT and to Oscar Gutierrez as chair, and to the other 11 experts from diverse countries. As you could see in the agenda, please next slide. As you could see in the agenda, there will be five presentations. The two first to introduce the proposal for the smart roads classification and a summary of the background. In the second part of the webinar, two additional presentations will be shared to introduce some main concepts related to the adaptation of connected and automatic vehicle to road infrastructure and our proposal for the smart roads classification. The third part of the webinar will start with first short questionnaire related to the proposed objectives. After your answers, Javier Camacho will share and comment the most important results, opening the discussion. After that, the last presentation related to possible application and management will be shared. Finally, there will be two additional short questionnaires to be answered and share the main results, both related to the proposal and the application and management. Finally, a general discussion will be opened, and to conclude, Oscar Gutierrez will share the last words. Thank you very much, and up to you. Thank you.
Thank you very much, Alfredo. I think we can move on to the smart roads classification and presentation. Sorry for the background noise. With David, if that's okay?
Yes.
Thank you, David.
My name is Alfredo Garcia, and I'm professor of highway engineering at Universitat Politècnica de València in Spain. In this initial presentation for the introduction to the smart road classification proposal, I will summarize the previous road classification system to finish presenting all the objectives we have defined for the new system. Traditionally, road classification systems have focused mainly on two factors, mobility and accessibility. Recently, new classification criteria have been considered, such as those proposed in the context of a TRB project presented in 2018, where different types of road users had been incorporated, as well as various contexts from rural to urban core and functionality. However, none of the classification proposed before 2020 took into account the incipient advent of autonomous and connected vehicles, which will of course require the definition of new criteria to classify our roads. The project, entitled Connected Roadway Classification System, developed in 2020 by the TTI at Texas A&M University in the United States, developed a new framework for a road classification system that includes the characteristics of autonomous and connected vehicles. This road classification system establishes 4 road categories or levels, from a level 1 in red, associated with a road design or maintenance that does not meet current criteria, to level 4 in green, which is related to a design that supports the operation of most autonomous and connected vehicles and communicates with vehicles. It is noteworthy that they set a time horizon of 10 years to reach the maximum level. To assess the level of automotion enabled by a road, 3 domains were considered. First of all, talking or communication associated with connectivity between vehicles and infrastructure, seeing or perception associated with the recognition of road markings and signs by autonomous and connected vehicles, and finally, simplifying, associated with the degree to which mainly the geometric design and pavement conditions facilitate the operation of these vehicles. However, some issues included in the classification are still unknown, as it is shown by traffic lights. Further research is needed to establish more clearly some of the criteria on which this classification is based. The main goal of the InfraMix project, funded by the European program H2020, was to prepare the road infrastructure to accommodate the introduction of connected autonomous vehicles from the perspective of connectivity. Thus, depending on the compliance of the different characteristics shown in this table, a total of 5 categories of roads or ISAD levels were defined based on the infrastructure support levels for automated driving, ISAD levels. As you can see on the right, different levels are assigned to road section or element, not for a whole road. Thus, level E is the lowest level, and it represents a conventional infrastructure which does not offer any support for connected vehicles. At present, there would be many sections with a level D, consisting of a support of digital maps with static information of signs. Level C would complement the previous one by adding variable information such as incident warning, meteorology, among others. In the level B, the infrastructure is also able to exchange microscopic traffic and road condition information with vehicles in what is called cooperative perception. Finally, level A will allow cooperative driving to improve road safety and operation. As a summary of the classification system, we can say that all the previous one did not contemplate logically the new vehicles. The new USA proposal did not contemplate the diverse user and did not include many of the factors involved in the new phenomenon without considering possible thresholds. The ISAT proposal focused exclusively on connectivity and the necessary digital infrastructure to support it, but it did not go into the characteristics of the physical infrastructure nor into the diversity and limitation of automotion. Additionally, none of the previous systems integrate dynamic road conditions. Definitely, the proposed road classification system integrating connecting autonomous vehicle characteristics are based on diverse approach and harmonization is needed. The main objective of this special project is to explore the feasibility of a new smart roads classification system that could provide information to users and vehicles about the smart roads level being the base for an efficient road planning of investment on physical infrastructure and digital infrastructure to improve the operativity of automated driving and the benefits of connectivity. Finally, allow the necessary dynamic management considering diverse variable factors. A safer, more sustainable, efficient, and comfortable road network is expected. Other objectives are related to design and propose a framework that can evolve and be detailed in the next feature, taking into account the new and improved technology, the research finding, and the best practices of its application. Additionally, the new system should be based on the different automation levels, the necessary connectivity, the current road network characteristics and classification, and the diverse users. Some specific objectives have been proposed for the smart road classification. There should be a common language to facilitate all stakeholder communication, useful to facilitate the application by road administration and operator for planning, investment, and management, standardized to be included in a normative framework, interoperable to facilitate data exchange, robust to assign an adequate and coherent smart level, consistent and simple to facilitate message for users, and it should be integral, dynamic, and flexible to facilitate evolution and transition. Finally, the new system should not mean liability for road administration and road operators. Thank you very much for your interest in this special project about smart roads classification.
Thank you very much, Alfredo. And if you have questions or remarks, please use the chat so that we can prepare for the Q&A section of the agenda. The next item is literature review, which will be presented by David Llopis and Jose Montserrat. Thank you.
Hello, my name is David Llopis, and I am an assistant professor at the Universitat Politècnica de València. In this presentation, Jose Montserrat, who is a professor at the UPV, and I are going to present the most important aspects regarding current automated driving and connectivity limitations. Particularly, a total of 12 attributes have been differentiated concerning automated driving limitations. Each attribute is introduced and discussed in the next slides. Regarding road typology, the capacity of a road infrastructure will change with CAVs penetration, and some studies indicate an increase in capacity about 40% and 80% in cities and highways, respectively. Likewise, high-capacity roads are already ready to integrate CAVs, where some new designs, such as dedicated lanes, are being developed to easy CAVs integration and performance. It's known that current road geometric design guidelines were developed for a human driving. This makes CAVs operation on demanding road elements, such as sharp horizontal and vertical curves, more difficult. In addition, there is an important difference in visibility, as the point of view of the human driver is different from that of the sensors. An important new speed concept was defined to this regard, the automated speed. That is the maximum speed that an automated vehicle can reach at a specific road element. Related to this, lane width, shoulder width and type, and median configuration also influence CAVs performance. Lane detection and tracking, as well as identification and recognition of road markings on the pavement, play an important role in driver assistance systems, vehicle guidance, and route planning. The most important factors affecting on it are contrast, geometry, pavement type, environmental conditions, and obviously its maintenance. Specifically, a 3:1 contrast ratio between road marking and pavement widths of 150 mm and asphalt pavements facilitate lane detection. Most traffic sign recognition systems recognize only a few types of traffic signs, being the most important ones those related to the speed limits and priority of way. Some problems during the detection can arise in case of transverse distances longer than 10 meters, orientations greater than 45 degrees, or when multiple signs are present. Connected vehicle technology could significantly improve the operation and safety of traffic at signalized intersections, thanks to vehicle communications. However, CAVs currently have difficulties to recognize traffic lights under special light conditions. For instance, at night time, yellow and red lighting colors could be visually recognized to the same color when processing the image. Moreover, asphalt pavements provide a better CAVs performance than concrete pavement, as the first ones ease the contrast between road markings and pavement. It's clear that CAVs require a good pavement condition. Road distresses, old road markings, and cracked sealing might lead to system disengagement. As CAVs operation depends mainly on vision cameras and radars, unfavorable weather conditions, poor light conditions, and sun glare make CAVs automation harder. Regarding vulnerable road users, it should be noted that their behavior is unpredictable. This means that very complex algorithms must be developed to ensure a proper road safety level. In addition, their dimensions make object detection more complicated. The identification and interpretation of roadworks and temporary emergency signage are not possible right now because of their particularities. They coexist with conventional or regular signage, and their location usually hinders their detection. Finally, it's important to remark that the speed is a critical factor in CAVs performance. Automatic driving assistance systems are usually limited to a specific range of speeds, and road marking recognition might become very difficult at high speeds, as the system has to process the gathered information faster.
With respect to the connectivity limitations, we have two different technologies available for the connectivity in our roads. The first one is to use the cellular technologies we have today, like mobile communication systems like LTE, 5G, or so on and so forth. And the second option is to move to the Wi-Fi area to use these local broadcasting technologies that are available. With respect to the first option, what we call the cellular V2X, we have some pros here to consider. First is that we have the eCall is mandatory in the European Union by 2018, and similarly happens in the United States. It's quite common to have full coverage in our roads thanks to the mobile network operators. And also we have two releases of two different technologies available. The first one is the standard LTE, applicable to the cellular V2X communication, release 14. And also recently, just 1 year ago, we have also the version of release 16, which is applicable to the 5G technologies. This market, the cellular V2X, is already into production, and we have several chips that can allow us to connect our vehicles with these technologies. As I said, the second option is to go to direct short-range communication. We have some pros also, for instance, related to the cost and also to the market adoption of this technology, but has also some cons limited to the range and also how much they can scale up with the traffic. With many vehicles, these kind of technologies based on the evolution of Wi-Fi are not behaving quite well. So the final conclusion here is that it should be better to go to a versatile framework supporting several wireless technologies, because this comparison will allow all the stakeholders to feel comfortable and to go into the communication of our vehicles the sooner.
Thank you very much for your attention and interest.
Thank you, everyone, and thank you very much to our presenters. They were in the video recording, but they're also present here. So thank you to Alfredo, David, and Jose. The next segment of our agenda today is focused on smart road classification, of course, half an hour approximately, adaptation of CAVs to the road infrastructure, and a proposal, like a trial maybe, for smart roads classification. Javier, the floor is yours. Thank you.
Good afternoon. I am Javier Camacho and I'm assistant professor, and it's a pleasure for me to introduce you the adaptation of CAVs to the road infrastructure. This part is divided into 3 different sections. First, we will see what is the operational design domain and its implications on CAVs, on connected and automated vehicles. Secondly, we will see the adaptation of this concept, the ODD, to road infrastructure. And finally, we will review the ODD implementation roadmap. Let's start with the operational design domain definition, ODD. This is a very important concept that you will see a lot today. According to the Society of Automotive Engineers, the ODD are the operating conditions under which a given driving automation system or feature thereof is specifically designed to function, including but not limited to environmental, geographical, and time of day restrictions, and or the requisite presence or absence of certain traffic or roadway characteristics. Then, as you can see below, we have a picture of representing a road segment and 5 different factors. Those different factors are highlighted in green, the parts that meet the vehicle's driving automation system's ODD. In red are the parts for which the factor does not meet this condition. Then, the parts of the road that meet all conditions for all different factors mean that the driving automation system can perform and are represented in green for the ODD. The parts that at least one of the different factors is in red does not comply the ODD definition and therefore is out of the operational design domain of the system. It's important to see that the ODD is a definition from the vehicle side, from the driving automation system side. It means one system or other system for different vehicles may present different ODDs, so the sections of the road that meet the ODDs may be different for all vehicles. Well, after seeing the importance of the ODD definition, we have to refer to its usability. To have a usable definition of ODD, a practical one, we should have a comprehensive list of all different factors that could influence, that could be part of this ODD. I mean, for instance, geometry related to the horizontal curve radius, to the presence of spirals, the crest vertical curve, the environment, and many other things that influence how a driving automation system works or may prevent it from working. This list, or having a very comprehensive list, is a very complex task that is still starting to be developed. Here we have 3 examples of taxonomies. The taxonomy provided by the British Standards Institution is the example you can see in the figure. There is another one from the European ITS platform and another one from the Society of Automotive Engineers. Having this comprehensive list in the future will be very, very valuable, so for which driver or car makers or vehicle manufacturers could explicit the conditions for the driving automation system. This list could be therefore compared to the road geometry or to the road conditions, so we might be able to know where and when the driving automation system works without disengagements. Now we are going to remember the different levels of automation introduced by the Society of Automotive Engineers. There are 6 levels, 5 of them for automated systems, 1 of them, level 0, for completely human vehicles. Level 1 systems are the systems that are able to control lateral or longitudinal driving tasks of the vehicle. If a system is able to control both longitudinal and lateral motion of the vehicle, we refer that as a level 2 vehicle. However, the system is not able to control the environment. Level 2 vehicles may control the position of the vehicle in the lane and also the speed. However, sometimes these systems are not infallible and may disengage. and disengagement is an unexpected release of control to the driver. Therefore, the driver must be attentive to the road, attentive to the environment and the driving task. In fact, here, the driver is still the human, is not the system. For level 3, the situation changes a little bit. Level 3 vehicles, for level 3 vehicles, the system is able to monitor also the environment in addition to control the driving task, and disengagements may not be sudden. In some occasions, the system may be able to foresee those disengagements and ask the driver to resume monitoring, resume the attention to road monitoring and take the action. Level 4 vehicles do not require or do not present disengagements. In fact, level 4 vehicles, level 4 driving automation systems are the systems that are able to drive autonomously without any driver intervention or necessity to take control along a ODD compliant section. So, in other words, if the road segment meets the conditions of the operational design domain of the vehicle, the driver is not required. The system can take full control and monitor the traffic. However, this only happens on all sections that are fully compatible with the ODD. Finally, we have level 5. Level 5 vehicles are the driving automation systems which are completely free of any ODD restrictions. This means that a level 5 vehicle should be able to operate anywhere and there are no restrictions. Now we are going to extend the definition of ODD to the road infrastructure. As we said before, the ODD definition is from the vehicle side, meaning that one vehicle presents one specific ODD and it refers to the characteristics that should be met for this driving automation system to work autonomously. These characteristics are different from the characteristics of other vehicles, and so on with all vehicles along the road. So in the proposal we have included a new definition, which is the operational road section, ORS. The operational road section refers to the road characteristics that meet all existing vehicles ODDs. To clarify that, we have here one picture that represents again one road segment. And now we have 4 different rows that show for 4 different vehicles the compatibility of their operational design domains. In green, we have the zones that are compatible, and in red, we have the zones that are not compatible with the road segment. If we sum up all characteristics of all vehicles, we have the ORS at the bottom. This section, we have in green all zones that are compatible with all vehicles ODDs, and in red the zones that are not compatible with all vehicles ODDs. If we extend that to all vehicles, the green parts would be all the zones along our road network that are compatible with all vehicles. Then, if we can clarify, if we can obtain which road characteristics make compatible all operational design domains, we will be able to extend these characteristics to all our road network, and then we will increase the applicability of all automated vehicles. In addition to this definition, there are newer definitions like restricted operational domains or operational design conditions, which are not important today, but also refer to the extension of ODDs to road infrastructure. Some additional important definitions are the minimal risk condition and minimal risk maneuver. This definition is important especially for level 4 vehicles, and we are going to focus on the right diagram. Here we have the vehicle performing the dynamic driving task, and it approaches the exit of the ODD compatible zone. In this case, the vehicle warns the driver that to resume the manual control before entering the final zone. If the driver is able to respond, then it resumes the monitoring of the environment and the driving task and continues manually. But what happens if the driver is not able to respond? For instance, he's asleep. In that case, a level 4 vehicle is able to take control of the system and manage a minimum driving task in order to keep the vehicle to a safe zone. For instance, parking at the shoulder, at the right shoulder, left shoulder, or even keeping the vehicle in a low speed mode to reach for instance, the next intersection or the next interchange and keep the vehicle out of the traffic stream. The minimal risk condition is in fact the condition that minimizes the risk of this vehicle. For instance, left shoulder is more risky than parking on the right shoulder, so in most cases. So right shoulder should be a minimal risk condition compared to the left one. Or keeping the vehicle to the next interchange would be even less risky than before. It depends on whether the system is able to take the vehicle safely to that part or not. We will see an example later on. The minimal risk maneuver refers to how we reach that condition. For instance, if we are in a freeway on the left lane, maybe parking on the left lane, if we have room enough, it's safer than crossing all lanes to reach the right lane. And here we have one example about how to place a minimal risk condition zone for vehicles. These minimal risk condition zones are also called safe harbors. In that case, for instance, if our level 4 vehicle is very close to this interchange, instead of parking on the right shoulder, taking the vehicle to these parking lots would be safer, if possible, of course. There is a long way until ODDs are become explicit. We have a fully comprehensive list of all factors for the taxonomies. However, although nowadays it's a difficult task, we have seen some improvements, some research on this aspect. One example is TomTom Road Check feature. In this feature, this software is able to compare road geometry and conditions to every single specific driving automation system ODD. Then the GPS device using this software suggests the driver whether to activate or not activate the driving automation abilities. This is one example, and this of course is likely to become more frequent in the near future. Another recent contribution to the state-of-the-art of CAV performance on road infrastructure is the LOSAD, the level of service for automated driving. This will be later explained in the following section, but it was introduced by the Highway Engineering Research Group and focuses on the CAV performance on a certain road segment. If for instance, if we have a segment with many disengagements, this level of service will be lower, and if we have a road segment with a very, very good performance for CAVs, the level of service will be higher. I am not going to explain more on this because it would be later developed in this seminar. Thank you for your attention. Hope this has been useful for you to follow the seminar. And now we will see another video about the Smart Road Classification proposal. In this section, I'm going to explain the main core of the Smart Road Classification proposal. The main goal of the Smart Road Classification proposal is to clearly indicate how roads interact with CAVs. CAVs, as you know, is the acronym for Connected and Automated Vehicles. So we thought that having two explicit indicators to reflect both connectivity and automation would be a good idea. These indicators are LOSAD and ISAD. On the one hand, we have LOSAD. LOSAT means Level of Service for Automatic Driving. This is a new concept which indicates how favorable are the geometry, environment, and other characteristics of a road segment for automation. On the other hand, we have ISAT. As you already know, ISAT means Infrastructure Support for Automatic Driving. It was first introduced by the Infomix project, and it refers to how well a road infrastructure supports connectivity. So, we use both indicators as an input for our smart road classification proposal. We define 5 different levels, which are from worst to best support for CAVs, human way, assisted way, automated way, full automated way, and autonomous way. We will tell you the differences later on, but it's important you to know that these 5 levels have no direct connection to the 5 say levels of vehicles. Let's now see the differences between the LOSAT levels. LOSAT A applies to road segments that continuously support automation. In other words, the road segment is fully composed of an operational road section. Thus, level 4 vehicles would not release control to drivers, and lower automation levels for vehicles would experience very few disengagements. LOSAT B is similar to the previous one. However, some dynamic aspects, for instance weather or disengagements, may reduce the compatibility of some driving automation systems. This could require the intervention of drivers. For instance, also an abnormal density of disengagement might also reduce LOSAT A to B. LOSAT C is different. In this case, LOSAT C does not present a continuous operational road section, so some or even many level 4 vehicles may require the driver intervention. Like before, the number of disengagements for levels 2 and 3 increases too. The same applies to level D. Level D is an extension of LOSAT C. In this case, operational road sections are shorter. This means that the number of takeover requests, disengagements, and so on will increase for most vehicles. And finally, we have LOSAT E. As you may imagine, LOSAT E applies to road segments for which their geometry, environment, or other conditions prevent most driving automation systems from performing autonomously. Once we know the differences between the LOSAT levels, here we have a very important question. How do we apply it? Determining whether a road segment is LOSAT A, B, C, D, or E should be based on measurable factors that we know that have an impact on automation. We have proposed these factors, the ones you are seeing on the screen, which we know that are connected to disengagements. These factors are related to physical and digital infrastructure. In addition, we have proposed some thresholds to classify road segments depending on the different categories. However, these factors and thresholds are not important now. With the deployment of CAVs, additional factors will be needed, and thresholds will also change to reflect more accurately their impact on automation. Let's shift to the ISAT. As explained before, the ISAT levels represent the capacity of the road segment to support connectivity. These go from level A, which even supports cooperative driving, to level E, which represents a conventional infrastructure with no digital support. The ISAT levels were proposed by the Infomix project funded by the European Research Programme Horizon 2020. In addition to the levels, those researchers proposed many factors and thresholds to classify road segments in the different types. Those factors are the ones you can see for the digital infrastructure. For connectivity, the scenario was quite more open since the real scenario is still not defined in a European or even a worldwide perspective. We have proposed some factors, but those thresholds will be later defined more accurately as the scenario becomes clearer. Now, we are going to see how the different LOSAT and ISAT levels interact to produce the different 5 smart road classification levels. The first case is when we have a very poor LOSAT level and it does not depend on the connectivity. In that case, the road geometry environment produces too many disengagements. Therefore, drivers should know or must not activate their automation capabilities, because they will not be able to use them appropriately along the road segment. Next step is when we have a not so poor loss-out level, and again regardless of connectivity. In that case, those road segments may be able to allow 1 minute, 2 minutes of continuous automation. It also, of course, depends on the capabilities of the vehicle. In that case, depending on the circumstances, drivers might be willing to activate their system because the infrastructure is not so poor. This situation slightly changes when we have a better automation, loss-out A, B, or C, but we don't have connectivity support. In that case, a level 4 vehicle might be able to drive along the road segment. However, in that case, the infrastructure cannot send information about the ODD configuration, about the ODD start and sections, and so on. So the vehicle is not able to perform as best as possible. The vehicle cannot determine with sufficient time, to plan with sufficient time, takeovers, and might reduce its performance. What happens if we have not the best infrastructure, loss-out C, but we have connectivity? In that case, the infrastructure can send information to vehicles about the ODD, initial, final section, about the safe harbors, and so on. So the information that the vehicle cannot see with its sensors can be sent to the system. Therefore, the vehicle can plan takeover requests. However, in that case, the road segment might not be continuously operated in autonomous mode. This again changes when we have loss-out A or B and we have connectivity. In that case, level 4 vehicles may experience a continuous ride without human intervention, because the infrastructure is very good, the physical infrastructure is very good, and also the connectivity sends information about all the specs that I have said before. This is the best option, this is the best category. However, we have a remark here. If we have also support for cooperative driving, we have the autonomous way road segments. In that case, the infrastructure, the physical part of the infrastructure is the same than for full automated way. However, in that case, we can close the road to only level 4, level 5 connected and autonomous vehicles. And in that case, we can send information about the cooperative driving. In other words, we can, from the infrastructure side, manage or micromanage all vehicles according to our needs. For instance, improving performance or in order to prevent safety hazards. The previous chart can be rearranged following a diamond-shaped layout, as you can see here. In this case, we have the same combinations. However, the shape highlights a bottom-to-top path to improve a road segment. Some combinations have been cleared and marked with an asterisk. This indicates that these combinations should be avoided for logical reasons. For instance, enabling cooperative driving in a road segment that triggers continuous disengagements would not provide any benefit to drivers. We wanted this classification system to be comprehensive and as useful as possible. We've seen how the LOSAT and ISAT can be used to determine the smart road classification level of a road segment. However, we thought that in some cases it would be more practical to determine the smart road classification of a road without previous calculation of these parameters. This can be done by directly applying the underlying LOSAT and ISAT factors. The results would be the same, but road administrations and operators would operate a little bit different. Since all factors are made explicit, this way to proceed is called the detailed classification system. Keep in mind that the results are the same, regardless the way to reach the smart road or the smart level of a road segment. The detailed classification system is a set of 5 tables, one per each smart level. Every table summarizes the requirement for the different factors to evaluate. Thus, these tables work as a checklist that could be used by road administrations or operators in a very simple way. You may see here some factors that were not before, such as minimum radius, minimum K, and so on. The explanation is that we have decided to divide the ORS related factors into their most specific, their most practical values to keep it even more simple. Like before, the specific factors and thresholds are not static and will for sure change in the future. Instead, the important thing here is the interaction that every road segment type produces on CAVs. In that case, since human way segments are the worst one for automation, the table does not present requirements for the infrastructure. This is just a part of all factors. The situation changes for assisted way road segments. In that case, we have some factors and thresholds that should be ensured by road administrations or operators in order to classify a road segment as assisted way. In this case, for instance, we have a minimum radius of 250 meters, equal or higher than, a minimum K equal or higher than 10 meters per cent, or a certain lane width range. If a road segment meets all these factors, then the road segment can be classified as assisted way or above. If not, the road segment would be classified as human way. But in the right part, you can see two columns. The second column stands for the requisites that should be asked for vehicles. And in this case, you can see that two requirements are asked for them, both of them related to the speed. Speed is a very important aspect that will be explained as follows. The speed at which a vehicle operates is very, very important, and it should be further studied in the future. For instance, it would not be adequate having a vehicle operating autonomously at 60 km per hour along a freeway. It compromises safety, it compromises performance, and so on. Thus, vehicles should also be asked to make sure that they can keep a certain speed threshold if performing autonomously. It means that they can reach a certain speed, close to the speed limit, for instance. These thresholds should not be a static value. These thresholds should be a variable according to the road section, for instance, according to the curve sharpness, visibility, or other aspects. We have proposed the speed range to be a function as the speed limit of every single road section, for instance, tangents or curves, but more has to be said in the future. We now go back to the smart road classification factors and specifically to the automated way road segments. In that case, we have more additional requisites for the physical infrastructure, wider ready, for instance, and we add specific requirements according to connectivity, especially vehicle to infrastructure connectivity. These factors become even harder for full automated way road segments. In that case, remember that these have a continuous operational road section. Therefore, those requisites, the radius, K, and so on, should be the ones that make sure that all level 4 vehicles can drive autonomously without intervention of the drivers. These factors, again, will be later refined once we know more about this, about the level 4 vehicles. We also propose that these cutting-edge road segments are proposed for high-end two-lane rural roads and also freeways. Finally, we have the best smart level, which is the autonomous way. This is an extension of the full automated way road segments. However, in this case, we have even better road geometric characteristics because they should also meet all vehicles' operational design domains. And we also have other dynamic variables, such as, for instance, rainfall intensity, that should be the best, should be under control. As indicated before, the most remarkable difference compared to previous segments is that these ones present cooperative driving support. Therefore, only level 4 and level 5 vehicles could drive or should drive along these sections. So these are proposed for some critical freeway road segments or for dedicated lanes on already existing facilities. Now, to sum up, here we have the diamond-shaped diagram of the smart road classification. We can see both waves of using the diagram at the bottom, either with ISAT and LOSAT with different factors, or directly from the connectivity, digital infrastructure, and physical infrastructure layers without going through the ISAT and LOSAT factors. At the top, we can see how this classification system is related to users and road typology. Administrations and operators could apply special restrictions to users depending on the smart level of the road. The same happens with road typology. We have proposed full automated way and autonomous way segments be deployed on cutting-edge two-lane road segments and freeways, but this is a decision that could be changed or taking a different approach by road administration and operators in the future. Despite this classification tries to fill the gap for CAVs, all users may interact with it. The top left table is included in the document and details how the different users interact with all 5 smart levels. Connectivity and autonomous capabilities of users have been included in this table too. The bottom right table is also part of the proposal and connects the different say levels with the smart levels. Red interactions are proposed to be prohibited, while the yellow ones would limit the capabilities of the vehicles, either by requiring manual driving or limiting the speed. Thank you for your attention. Hope that you have enjoyed this introduction to the smart level. And now we will answer your questions and give you a brief questionnaire about this classification system.
Thank you very much. Thank you. We had lots of questions in the chat, and that's really great. Patrick Manjak here again. But before we move on to the Q&A, there's first a first question about the objectives and the discussion about the smart roads classification. This is going to be presented by Javier, and I think Javier, yeah, please, Javier, feel free. Do you want to present this slide now for everyone?
Yes, can you hear me? Thank
Yes,
you
well,
very much. Yeah, thank you very much for your introduction. Thank you very much for your questions. And it's a project that deals with our intention for the project is to also to present you the classification system and also to get your feedback. Some of the questions you have asked us are especially related to this feedback. So we are going to do 3 different questionnaires. The first one is right now. And in a couple of minutes, 5 minutes, you can directly answer it. David, can you copy the link in the chat, please? So please now access that link, or you can also use this QR code and answer that. After a couple of minutes, after 3 to 4 minutes, I will share the responses so we can debate a little bit on that. We have near 40 responses so far. I will share the results in 30 seconds to 1 minute.
Very good. Thank you.
Thanks to you.
Everyone, after that, will be able to enter a question Q&A. So 10 minutes for that after this first questionnaire. Thank you.
Perfect. Thank you very much. So here we have the live responses. We have up to now 52 responses. If you are still answering the questionnaire, please keep doing so. Important is your feedback. And as you can see here, the distribution of the type of stakeholder is quite about road engineering consulting firms, road administration agencies, and also academia. As we are having in the project, there is a problem, there is an issue with the responses from automotive industry. Many of you have also highlighted this issue, and this is also happening. So yes, we're having problems with that, but it is something that we feel it necessary, as we will discuss later. But considering this smart road classification system to be deployed in the near future, about near 4/5 about the score, which I think it's most of you agree on this, and about the different objectives for the smart road classification. Universality to be applicable to roads worldwide and all types of roads a little bit lower than 100%, which is more or less the rest. And the no liability for road administrations or road operators. It seems that slightly more than they have. You agree on this, but near 40% don't agree on this statement. We will discuss about that later too. You have also provided here more comments about the response about a higher interaction with CAV industry is necessary. We strongly agree on this. Moreover, it's not something that we agree, it's something that we feel it necessary. Safety on data, also to work with autonomous vehicle companies, the same. Also, some about the low medium income countries. Yes, the applicability of the system will differ depending on the country, depending on the country needs and so on. This also is part of the project goal, and will be analyzed in the final version. Today, we're not centering on that, but will be part of the final report. And also, especially your feedback from all types of countries is very important to us. And well, maybe aspects such as weather information, disengagements, and so on, for instance. Universal applicability may not be feasible, might be, we don't know, depending on how our things go, like universality, like the standard language, and so on. Well, so this is a quick sneak peek on your answers. If you want, Patrick, we can move to questions and answers if you wished.
That would be great indeed. Thank you, Javier. And thank you everyone for contributing to this questionnaire. It's not closed, so feel free to continue sharing information. And please don't forget about the questionnaires we've shared earlier. They will be shared again at the end of the seminar. So now we have 10 minutes for questions and answers, even though we're 5 minutes behind schedule. So everyone, there's been a number of questions in the chat, and I would like to give the floor, if that's okay, with everyone, to Andrea Schaub and to David Johnson, because I think you have something to say about the role of manufacturers, vehicles manufacturers. So maybe we could start with Andrea Schaub, so that maybe in 30 seconds you could present your question, and we will try and discuss that. So please, Andrea, if you are willing to do that, the floor is yours. You can turn on your microphone, I think. Yes,
I'm sorry, can you hear me now?
Sure.
Yeah, I just had problems with my internet connection. Yes, I'm Andrea Schaub. I'm from Austria. I'm a researcher. And my question was about the loss sets. And I think that they are highly dependent on the ODDs. Mm-hmm. And basically my question is, how do you get these information from the ODDs of the vehicles? Because I think that a lot of manufacturers right now do not share this information because their technologies are still under development and they do not want to share their weaknesses, and they are also trying to adapt to any infrastructure anyways. Mm-hmm. So how do you get this information? And yeah,
sure. Thank you very much. Well, we agree on that. We have a problem with ODDs. The fact is that the ODD concept is very clear one. It's a very important one. Having clear ODDs would be perfect to all of us to summarize operational road sections and so on. However, we think that the problem is not the real application and transferability of this information. Maybe, for instance, defining an ODD for a single factor, for instance, horizontal alignment, we think it's not difficult. We think it's somehow easy or not very difficult to define up to which road curve radius a driving automation system is able to work. For instance, lower radius is more difficult to drive along. It is also easier to define the road width for a vehicle. However, we think it's really, really difficult to address the interaction with all different factors that are part of an ODD. For instance, maybe the vehicle perfectly works on a sharp curve or a medium curve. Probably the vehicle works perfectly also in some light conditions and in a tangent. However, if you mix these light conditions and this curve, being both of them within the ODD, within the factor good conditions, maybe this interaction is not good for the ODD. So probably the problem relies on capturing these interactions. Probably we don't know because we have asked the vehicle manufacturing industry and we had little response. Probably because they are also struggling at knowing these aspects. And I think in a short time, I think that probably the ODD will not be will not be clear the future. Maybe it is, maybe it's not. But probably what we really feel very, very important is having information about the disengagement of existing vehicles. Because with existing vehicles, you know that there are technologies, artificial intelligence technologies, for instance, neural networks and so on, that could retrieve all data from all these engagements of vehicles and determine a more accurate ODD, a real ODD obtained from real world vehicles, and that would be a more accurate one. So probably the way does not come from ODDs, but from these engagements.
So thank you very much for this. Indeed, the project is not about developing a very specific classification. It's about understanding the constraints and feasibility and who road operators should be working with. And this question is really relevant. There was a similar question, but that I think was very important as well from Jaco Klang. Jaco, are you there? Maybe no.
Yes, I am.
Okay, go ahead, please. Thank you. The floor is yours.
Yeah.
Go ahead.
Okay. I have so many questions.
So 30 seconds for the question. If you have 30 seconds for the question you wanted to ask. In the chat, you mentioned, you asked the question, has the classification been discussed with the automotive industry?
Yes.
And what are their needs in terms of transport infrastructure?
Yes.
So, a massive question, indeed. So, Oscar Gutierrez, do you want to take that question? Or maybe Alfredo?
I think I've answered him. Well, we have problems with the automotive industry trying to have the feedback. So, but this is a complicated issue. It's not easy. We have raised many interesting questions from Jaco and from other people, and well, there's something, for example, the artificial intelligence, how we do it with it, and so the problem is that we have level 1, level 2. We have many different levels. So the infrastructure, we have to be prepared. Which are the demands of the vehicle constructors, of the vehicle manufacturer? So that's a very difficult challenge, and I think I will tell you at the end that it's not easy. It's not easy, Jaco, to face all these challenges. But we're working in this, and your questions and your feedback will be very useful for us. Thank you.
Thank you, Oscar. Next up, and that will be the last question for the moment, and we have another Q&A later on, so don't worry. Steve Phillips from CEDA. Steve, if you're around.
Yeah, thank you, Patrick. Thank you, Patrick. Got my microphone in the right place. Yeah, I think this is quite interesting, and I do like the approach that's being taken as in terms of trying to understand what the needs are and where the needs come from, and just to react on some of the comments I've heard. This, for us, this is not about responding to the needs of the vehicle manufacturers. This is about responding to the needs and the priorities of the NRAs, of the road authorities. We have, well, I don't need to tell this audience, do I? But we have, of course, many needs that we have to address and increasingly have to address, and I see this as responding to one of the opportunities that if we get it right, we can get the automotive industry to respond to our needs. And drive, literally drive the vehicles in the right way, and just by way of input. I mean, I think there's a number of aspects. Obviously, from the CEDA perspective, we are working as the European road authorities closely with the European automotive industry. We've had a number of discussions about this, and again, trying to relate to them. We have our needs, and this is not just about. The phrase I hate is, CAV ready infrastructure. Infrastructure is already there. This is not about changing it. This is about making sure that the CAVs are developing in the right way to respond to our infrastructure. And just as an example, and an area where actually I think the cooperation with industry is going very well, and I would like to replicate that here, is, for example, with heavy vehicles. Where we have smart infrastructure access programs. A lot of issues to do with exactly the same issues. Making sure the right vehicle is on the right road at the right time in the right conditions. So, let's not completely reinvent the wheel. I think let's go back to what are our core needs, and then address the automotive industry with a clear set of our needs and what we are prepared to offer. So I think what I've seen so far, I think really pushes in. I hope in that direction.
Thank you very much, Steve. That's a clear message. Focus on what road operators and what administration's needs are, indeed. Oscar, you raised your hand, I think.
Yes, I absolutely agree with Steve Phillips. Yes, road are there. We have anybody can say so about the digitalization, automation, but road are there very important. The industry need us, the cars need us, but we have to adapt as far as we can do to the new challenges. We can go back to the beginning of the 20th centuries when there were roads, but no roads prepared for vehicles. And we, the engineers or the people who were in charge of roads, we adapted our roads to the needs of the new of the cars of the new automobiles. So I think the future, well, we can reach this dialogue. This dialogue seems difficult between the road administrations and the automakers, but I'm sure that in the future we find some point of agreement, and at this point of agreement are users. We are devoted to users. For us, the most important thing are users in every road administration. So I think at the end, the automotive industry have to reach in, some kind of cooperation with us.
Thank you very much, Oscar. I think that's a key thing already that we will take away from this webinar. Focus on the needs of road operators and administrations, and discuss how we can engage with automotive manufacturers and OEMs. This is well noted. Back to you, Javier, for the next part of the presentation. Thank you so much.
Thanks to you. Thank you very much for all questions. David, can you connect your screen and share the fifth video?
Yes, of course.
Thank you. After reviewing the proposal of the Smart Road classification, we are now going to see how we can apply it. And this is not an easy thing for several reasons. The first one is that only a few CAV levels are a reality nowadays. The fact is that level 2 vehicles are becoming more and more common, but the first level 3 models are starting to appear, and levels 4 and 5 are really far in time. Second, there is a huge variability of driving automation systems, with diversity in disengagement and operational design domains. Data on these aspects would be very valuable to enhance the classification system and refine factors and thresholds, to know a little bit more about the impact on the different types of autonomous vehicles. Finally, connectivity and digital infrastructure are still to be fully detailed. The specific factors, which information will be provided to vehicles and how it will be provided. As you can see, many of these aspects are an issue today, but will not be in the future. Thus, the application of the Smart Road classification system will differ in time. We will differentiate the interaction of this Smart Road classification system from 4 different perspectives: road administrations and operators, from manufacturers, and other stakeholders. Let's start to what can road administrations and operators do with this classification now and in the short-term future. In this period of time, explicit information about these engagements and operational design domains does not exist, and the same happens with level 4, level 5 vehicles. Thus, administrations and operators should focus on the aspects that really impact level 2 and level 3 vehicles. And of course, strong research efforts should be undertaken to clearly determine which are the geometric and environment thresholds that should be used for it, should be used to clearly mark and clearly define the different Smart Road classification levels for these vehicles. In the picture, we have one example.
we can see how a road segment that may present different characteristics has been reviewed, has been assessed by a road authority, and upon these characteristics, the road authority has decided that it matches the requirements for an assisted way road segment. Thus, the road authority can install a vertical sign indicated for drivers that this segment matches assisted way characteristics, and this informs drivers, and they might take one or other option depending on this information. We will review that later on. In a more distant future, the situation dramatically changes because we will have data on disengagement, data on operational design domains, and also level 4, level 5 vehicles will be a reality and will coexist with lower automated vehicles. In that case, road administration and operators will have data, and with this data they could use that in order to determine and manage the different LOSAT and ISAT levels. Here in the picture we can see one example. We see two different diamond diagrams for two different road segments. As you can see, we have an ISAT and LOSAT distribution in green and red respectively, and the infrastructure and the administration can classify or can determine the percentage of every single level of LOSAT and ISAT. It can be put in the bottom part of the diagram, and this changes the distribution of the different levels. For instance, in the left diagram you can see a more near existing situation with a lot of road segments being human way, assisted way, and in the right diagram you can see a future situation in which we have a lot of segments as full automated way and also autonomous way. This aspect of the diagram can be used by administrations, operators to take or to undertake decisions about investments, what road segments should be improved and why. LOSAT and ISAT distributions could be also matched with the ADT, with safety aspects, also in order to prioritize one road segment or other. And it could also be used to see how a road network changes in time, or to compare different road networks for different regions or different countries. Now let's see what happens with users, again in a short and long term. The user perspective is extremely important because users are who are really using the level 2 and above vehicles. Without the classification systems, some level 2 drivers do not know when and where to activate these systems. This may reduce the confidence on the level 2 vehicles because some drivers might see many disengagement when unexpected. The goal for the smart road classification system is to clearly indicate which road segments are adequate to activate the systems and which road segments are not adequate. It's important to highlight that when indicated that a level 2 system has to be activated, does not mean that the driver can drive or the vehicle can drive driverlessly. It's important that the system may assist the driver, but the driver always has to keep an eye on the road. So not only clear indications for drivers about when and where to activate these systems, but also education campaigns should be undertaken in order to inform drivers about their responsibilities depending on the ADAS they are using. In a more distant future, physical indications for human way and assisted way would still be required. However, for higher smart levels, connectivity would be a reality. So with it opens thousands of new possibilities for higher smart levels. By using, for instance, digital information, data about roadway characteristics can be directly transmitted to the vehicle, not to the driver. The driver is not aware of it, but the driving automation system could use that to prevent or foreseeing disengagements. This would end into extending compatibility for level 2 vehicles. From the user perspective, they would just receive an indication that the road segments, for instance, can be driven driverlessly, since the vehicle will cope with all other information. So it will be very simple for the driver and very comprehensive for the vehicle. Now let's include vehicle manufacturers in the equation. Nowadays, level 2 vehicles can undertake actions based or only based on the information collected by their sensors. I mean the information that is directly captured from the road. However, this situation changes as we increase the smart level of the vehicle. For instance, for level 3, level 4 vehicles, we will need to compare operational design domains. We will need additional information to foresee disengagements, or maybe we don't need it, but we would be really benefited from having this information. Or we should also know the location and characteristics of the different safe harbors and so on. This information would be necessary or would be great to deploy automation capabilities. In addition, by knowing the geometric thresholds for the different smart levels, vehicle manufacturers could also set clear targets to test or to develop and test their vehicles, their driving automation system. Therefore, as you can see in the picture, road infrastructure users, connectivity providers, and vehicle manufacturers should work together, boosting their synergies and accelerating the development and deployment of CAVs. Finally, there are other stakeholders involved in the equation too. New private and public services will appear in the future. Some of them they are even not known today. Some applications could be for instance, to foresee disengagements sooner, or information about traffic and pavement conditions could be retrieved and transmitted from the road, and also managing the road through the information provided by connected and autonomous vehicles. Many other uses could be performed or might appear in the future that will show up in the next 5 to 10 or even more years. Finally, in the proposal, we have indicated some key performance indicators that could be used by road administrations and operators to see how well their road networks work. Here we have some examples, like the disengagement rate, the average crash rate involving CAVs, the smart road levels for the entire road network or any specific road type, and the same for ISAT and LOSAT. These KPIs in combination with traffic, safety, income, and any other aspects could be used by these agents in order to prioritize actions or to see how well their segments are performing. Well, thank you for your attention, and we will now go through 2 additional questionnaires and open debate about the possible applications. Keep in mind that the importance of the webinar is not only to give you a short briefing about the proposal we are undertaking, but also to get your feedback and your impressions. Thank you very much.
Thank you very much, Javier. So now we have, as you just said, 2 more questionnaires. So back to you. Thank you.
Thank you very much. I think you can hear me and you can see my screen again. So yes, we are going to the second questionnaire. The second questionnaire is short and close questions about you have seen. This is the link to the questionnaire. David, can you also share the link through the chat?
Yes, the link is in the chat.
Okay, thank you very much. So you can access via the link or via capturing the QR code. Again, we are leaving about 3-4 minutes for you to answer, and we will share the live answers. Thanks.
In the meantime, everyone, please note that we are maybe 5 to 10 minutes behind schedule, and we will try to stick to the 2 hours schedule as much as possible. But I hope most of you can stay for an extra 5 to 10 minutes if necessary. My apologies for that. While you are answering the questionnaire, please note that this presentation will be available from our website, piarc.org, and that the files themselves, the PDF files that have been used for the videos will be shared as well. So you don't need to take notes very actively. You will access that information in the next few days. Thank you.
We have 30 responses so far. Okay, 40 responses. I'm giving 30 seconds more. Perfect. So here we have the results so far with 46 responses. Please remember that you can still answer the questionnaire if you have not sent your response yet. First, were these results. We have, do you consider smart role classification system necessary for the deployment? Most of you, near 4 out of 5 of you, indicate that you see that necessary. About the ODDs and disengagements, you also consider that it's necessary. Slightly more on disengagements to be more important than for ODDs, but both of you consider this information coming from vehicles is important for the ORS and for the sake of the project. Also about the physical and digital road infrastructure information be shared with a variety of information providers. Again, you also vote for the sharing information. You 44 out of 50 people said yes. And about responsibility, which is very important, about the responsibility for establishing and updating the smart road level. I mean, determining whether a section is human way, assisted way, or whatever.
you feel that road administration and road operator are the most important, the ultimate responsibles, more administrations, followed by operators, probably because operators are behind the dynamic aspects and the administration behind the static ones. However, you in third place, but at a long distance, you see that it's a shared but all responsibility. The situation changes for the responsibility for using the smart road level. In this case, we have a quite more balanced distribution. First, you consider that automated vehicle with 21 responses is probably the highest responsible. However, the distance with the second one is shared by all is quite close. It's only three of you. So we consider that this is a shared scenario. There's responsibility for this, for using the system. And the level of understanding is a little bit lower than before. It's about 3.61 between 3 and 4, a little bit closer to 4, probably depending on the specific regulations or on the specific information that will be provided for each one of the partners or each one of the stakeholders. That will be clearer, but we will work on this direction. And I think it's better if we move to questionnaire 3, which is very, very important. So questionnaire 3, it deals, it's not this one, it's this one. The questionnaire 3 is composed of open questions about the applicability, barriers, opportunities, and challenges on this classification system. So again, please follow the same procedure. In this case, we will give you a little bit more time because of the open questions. You can access through the link and also using this QR. And after that, we will discuss the results and also open questions and answers as before.
The link is in the chat.
Thank you.
Please note that in 1 or 2 minutes, when the questionnaire is over, we will be able to move on to another section, moment for questions and answers. Thanks. Please, everyone, try and contribute. We're all aware it takes a bit more time because those are open questions, but everyone's input is really, really welcome. So please take the time to contribute to the questionnaire, and we will close in about 2 minutes approximately and move on to the Q&A. Thank you.
We have 12 responses so far. We're giving a couple of more minutes. Okay, we have 21 responses to now, so we will share the answers in order to not run behind the schedule more. So your comments, according to your comments, the applicability of the smart road classification in the near future to 2030 is about 3.6, 3.59. The benefits, the more important benefits you have outlined is that things will be more clear for users, probably also with lower accident rates, and well, road safety improvement was a very important one. About the concerns, challenges, and barriers, we can highlight some of them as, for instance, many stakeholders. We have to come to an agreement, not only from the infrastructure side, but also involving vehicles, involving connectivity providers, users, and there are many people in this equation. This is something hard to address, and this is something that we will change in time. We will discuss about that later in the question and answer section. Also, the regulations, harmonization regulations, expensive. The budget it has also been a common answer to this question. It also depends on the country, because some countries will be able to afford that from the beginning, others will be more later in time or with different needs, of course. Okay. and responsibility, and well, somehow those are the most important aspects. About the management stage, your feedback is that format is being carried out. The traffic control, also how do we apply, how do we force vehicles or drivers to use the segments or not, and how to engage the automotive industry, probably using or by talking through organizations. Some of you also have pointed out that regulation or mandatory sharing information would also be required, would also be needed, with transversal consortiums, so on. And finally, about the how PIARC should be continued with this topic and so on. I think this could be discussed later or by Patrick as you prefer, but well, we have a balanced equation with webinars, you agree on that, followed by partnering with other organizations, probably with vehicle organizations, for instance, we don't know, and new technical committee, but it is something that Patrick or Oscar could say. So if you want, Patrick, we can move to question and answers, or if you have any additional question. Micro?
Yes, here.
Yeah, thank you.
Thank you very much. Thank you, Javier, for the answer. Thank you to everyone who contributed to this questionnaire. So of course, we only have some of the feedback here on the screen, but that will be analyzed further in the course of this project. In the chat, there were a couple of questions, and I would like everyone here to maybe take the time to discuss this. And Davide Lopresti, I don't know if you're available here now still. Yes, he is. So maybe you can turn on your microphone, it's turned on. At some point, you asked a question about regulating the traffic at the entrance of the smart roads, and basically, again, interaction between the vehicles and the roads. So maybe you want to elaborate on that for everyone now.
Thanks, Patrick, and hi, everyone. Yes, Patrick, so in the scenario of using motorways with a mixed traffic, I believe that all this change is about safety. So if we do have that scenario, I guess there could be a discussion on how to allow certain type of vehicles rather than forbid other type of vehicles for the sake of safety, if that is our driver. So my question, even though colleagues reply, my question for everyone is possibly, should we have this type of discussion between road operators and possibly also the automakers?
It's a great question. Oscar, if that's okay, you chatted with Davide in the chat. Maybe you want to react to this question about...
Yeah, I answered, David, that well, we can have devoted lanes for automated vehicles, could be some solution. But I think the transition period, the vehicles have to adapt to the lowest level. What does it mean? That if a 5-level vehicle is in the road, it have to share the road with 0-level roads. This is my point. I don't know what happened in the future. If you don't make a special lanes for the different kind of vehicles, those vehicles have to be they have to be able to share the space with human drivers. So I think that the 5-level vehicles have to perform as well as the human. Well, I expected better. So when you are in a road as a human and you see other drivers, I mean live drivers in level 0, so you have to adapt to their reactions. So I think for me it would be not very difficult, but we can make those solutions. So making special lanes, special roads for some kind of cars and other kinds of others. But I think that we cannot left anybody left down or behind. So everybody have to use roads in the future, and we have to have a transition period that I think is difficult. Yes, I do agree with you, and we are very concerned about safety in those cases. But I think we are going to prevail, and we are going to find solutions.
If I may add some words, for instance, the level 4 and level 5 of our smart road classification is full automatic way and autonomous way. Both of them are quite similar. However, the difference is that autonomous way is a road segment able to provide a cooperative driving support. We think that for in 20 years, for instance, for now, I don't know, but in the medium to far future, to distant future, we may have many level 4 vehicles and even level 5 vehicles which are able to operate along our roads with a significant improvement on traffic performance and also safety. In that case, we agree with Oscar that we should keep the road infrastructure for all users, including drivers and vehicles of lower levels. However, we could use the characteristics of these cutting-edge technologies by adapting or by dedicating specific lanes, because we would be able to see the improvements in traffic performance and safety, but with dedicated lanes and not leaving out other users, as Oscar indicated. But this was the special focus of level 4 and level 5.
Thank you very much, Javier. I have a question from my side, which I shared in the chat already. And then Leila, you raised your hand. So the question I have maybe for Alfredo, or anyone. Steve Phillips said earlier, we need to focus on the needs, on our needs. What are our needs? Okay. And there was a nice diagram on some of the slides that said we need to discuss between road infrastructure, vehicle manufacturers, connectivity providers, and users. So my question for Alfredo, maybe, and anyone, is how do we do that? Because how we need to discuss, we need to focus on our needs. Okay, how do we do that? Because how do we make sure that this exercise is not an academic exercise?
Yes, yes, I believe that this proposal of a new framework for smart road classification could be a very good starting point, just for the road administration to be able to establish an open space to include the automotive and other stakeholders in the development of this classification, and in a next stage, the corresponding regulatory and legislative framework. But perhaps the first stage could be as a pilot. Some countries, some volunteer countries should or could promote public and private partnerships to develop some use cases for the application of this smart road classification. And after that, I believe that PIARC could collect and share all the best practices just to facilitate more countries around the world to be included in developing and progress in detail the final smart road classification. But it's absolutely necessary to include all the stakeholders around the same floor to be able to detail through different use case or pilots to obtain the fair results and the first issues and different solutions and share the best practices around the world. And for that purpose, I believe that PR can play a key role.
Thank you, Alfredo. So we understand that we should do it, but it's not easy. to discuss with vehicle manufacturers, connectivity providers, and even users. So, but that's, I think, is really, really, as you said, essential. Then Leila, you raised your hand. So if you're still here, sorry for the delay.
Yes, that's fine. Thank you very much, everyone. It has been a great pleasure being with you all together. So I am a PhD researcher actually in the topic of road safety, and that's why I'm all enthusiastic, and I have a background in telecoms engineering. So congratulations. I think it is a great match seeing you all together here. And with respect to my question, I think, yes, I have to touch upon the point that we are going to start thinking about sharing spaces in a road environment. And when it comes to assigning responsibilities, it would be very interesting to take up front a measure that we could understand who is going to take what, when, because in the case of an unfortunate accident, there are many, in this case, we have rules that are in place, but if it is the automation taking a leadership in terms of the events, it would be very interesting to hearing how could we make this as, for example, an exercise, because as everyone mentioned, we want to transit from the research to the real world. But I think this point of responsibilities would be very interesting to hearing from you on your views. Thank you very much.
Thank you very much. Javier, you had a question about this, so maybe you have something to contribute here, Javier?
Yeah, thank you. I think that's very, very important, but I think the most, we have a conundrum here, because I think the most important problem here is that we don't have a sound base for everything now. We don't have a sound basis for connectivity, also for the vehicles. We don't know how the different technologies of vehicles, how they react. We don't know how regulations will come in the future. So this uncertainty prevents us from, or is preventing us from creating specific and altogether partnerships to deal with this issue. I think this will be a scenario that with initiatives such as the one we are PIARC is doing today will be addressed in the future. But it's something that must happen, because now probably vehicles, probably level 2 CAVs can work with the data they can receive from their own sensors. They don't need the infrastructure anymore. However, with a level 3 vehicle, for instance, maybe the driving automation system does not need many information from the infrastructure. However, it would be really benefited from that information. And not to say, and nothing to say about level 4 vehicles, about the starting ending point of the ODD and or the specific dynamic data about the infrastructure. The infrastructure should provide what the vehicle is not able to see in order to extend the ODDs. So I think that in 5 to 10 years, industry should come to us, or not should, but if that has not happened before, but industry, a global partnership should be done or should be conceived in order to address and in order to set a sound basis for everything at that point. I think that's the most important issue now. I don't know if I have responded your question or thank you. So these are our thoughts, but it's a moving scenario, difficult. In the project, we will try to cover all different aspects and in order to see what we think it's going to happen, what may happen, and our recommendation to fast things happen.
Okay, thank you, Javier. Thank you very much. So lots of uncertainties, obviously. There's a question by Davide in the chat. Davide, please.
Patrick, yes. So I wanted to ask a question really for everyone, which is a little bit provocative, but I think is the right audience to talk about it. I guess we're talking about motorways here. So at least in this context, my personal view is that if we really want to arrive to decarbonization and improve safety, we should avoid mixed traffic and possibly use motorways as big railways for freight transport. So that is channeled and is efficient for transporting freight. In other words, again, it's my vision. I wouldn't allow having private driving on motorways, but we can have automated freight transport with big trucks. So my question for everyone is, considering this type of classification, right? Do we really need to allow mixed traffic in the future? And should we understand that this is a work for the transition to fully autonomous road? But should we consider also what is our target? And is it our target to have mixed traffic by allowing autonomous private driving on motorways? Or maybe there is some other option?
Thank you, David. I like your question about what is our target. I think it's a fair question. What we don't want is a solution looking for a question. Oscar, do you want to take this one? Do you want to chat back with Davide or anyone else, really? Feel free.
Yes, I think it's a wonderful question. Yes, because it seems that we are going to reinvent the railroad, the rail. So the good thing that we have with cars, we live in Spain. We have 46 million of people living here, and I think only 6 people, as far as I know, they have not access to a road, to a roadway, to a road, to a street, to paved or unpaved road. So that's mean how we are going to deal with it. No, I won't go to make a dedicated roads only for autonomous vehicles, or what happened with streets or with different kind of roads. So my point is that in the future, I hope that the level 5 vehicles, they were able to reach any point of the any point of the network or the country and so on. But say that, I also think that some kind of transport would be better if we do it by rail, not by vehicles, or or we can make dedicated roads to those kind of vehicles, for example, platoon and so on. This is a very good question, and it's a very, very challenging one. What are we doing in the future? But I think we in the future, at least as far as I know, we have to accept that that the trucks are essential for us, for our mobility, because is the only way that we can arrive to all the people in a country.
But I would like to talk about the vision of David, because just this year is the first century anniversary of the first motorway in the north of Italy. And just one century ago, our previous colleague discussed about how what not to dedicate a road only for motor vehicles. And the vision of the adapt of David is just the same one century after, and perhaps he is in a right way. At the beginning, in my opinion, at the beginning we started with some dedicated lanes, but perhaps in two decades there will be specific motorway or the current motorway only for cars.
Thank you.
Thank you, Alfredo. Really good discussions. Jean-Claude Roffet had a remark, and then we will move on because I see many people are leaving the webinar. Thank you. Jean-Claude, are you there?
Yeah, no, thank you very much, Patrick. Just about, the user needs. There are so many needs, depending on if you are a truck, a particular guy or a bus, or you have so many expectations. So my perception is that of course the ideal thing would be probably a channel lane with being specialized, but it will never exist anyway, except probably on very small stretch probably on some motorways. But the main important thing is, especially regarding now the different requests from the cities, from the urban, that road would be shared, and that's really the main important thing, to appropriate all of the needs for a common space. Yeah. So how to deal with that, I don't know, but I think the main important thing is coming back to the subject that to classify the road is very important to provide the road users, whoever is a peaceful driving and safe driving. So I think the classification of road is really a key element we have to work on. Of course, as a lot of people were talking about, we have probably to open the ecosystem to gather probably more cooperation from probably the road users, probably from the the automotive industry, because for the moment they think that they are not really taking the road in consideration, but they would have to, as Steve Phillips said, the road exists already, so they would have to take that into account. Thank you very much, Patrick.
Thank you very much, Jean-Claude. We now thank you everyone for your questions and remarks. I think it's time to wrap up. And Alfredo, do you want to present this online questionnaire that is still on, actually?
Okay. Please, despite you have answered the three short questionnaires, I would like to encourage you to answer the main PIARC questionnaire that includes some additional relevant questions. And here on the screen or in the chat, please, David, we will post or you can follow the links in the chat or the QRs for the three different languages, English, Spanish, and French. And please remember that the deadline is June 22nd. Thank you very much.
Thank you very much, Alfredo. And now, Oscar, you have the difficult job of concluding the webinar. Thank you.
Okay, as you can see, this is a difficult challenge. There's a lot of uncertainties we are facing with this project. And we also have, as you may know, a lack of information from the automotive sector. I think we can deal with it, and I'm hoping we are going to be successful with this lack of information. And we also have to be adapted for this for disruptive changes in the future. We can have things that we didn't expect, or better new technologies and so on, that we have to be prepared for this issue. So nevertheless, even we have all these difficulties, we have to take into account we have some strengths. One of these is the road administration operators that supports this work we do. The PIARC support, the staff of support, Patrick, the technical director, and other people that are helping us. The UPV, the University of Valencia, Politècnica of Valencia, that's helping us in making this project, and especially the road community. Every one of you have been very useful, and we are very grateful for your cooperation and for your feedback. You can see that it's not very easy. This issue have a lot of phases, a lot of could be contradictions, and well, it's a challenge that we are going to face, and we are sure. I'm sure that we are going to have a successful end. So I want to, as Steve Phillips and Jean-Claude said before, roads are the most essential asset, not only asset, the most essential service for the community, because the lives of the people, the economy, the wellness of the people depends on roads. So we are very important. Nobody can forget us. I think it's a very important challenge that roads prevail, and everybody have to count with us. So anyway, thank you very much for all your contributions, because the role of the roads, the service that we give to the human beings as a road people in the road community is very, very important. And we have to take in account, we have to collaborate with the new technologies, but keeping in mind that at least in the future, as I can see, road is the main way to communicate, the main road of mobility, the main way of intermobility, and to interchange goods and people and life. I also want to remember you that the next PIARC events are the next World Winter Congress, the 16th. This Congress will be not only devoted to winter service, but also to another things such as road resilience. This is a new way of doing things, not only take the opportunity for sharing another things, not only winter maintenance. Also, this will be in Calgary, Canada next year in February. This is a virtual format. And the other thing could be interesting will be the SURF 2022. This is the 9th symposium about pavement characteristics, special surface characteristics of roads, that will be held in Italy in September from next year. We expect it not to be in a virtual way, but who knows. And the second PIARC International Conference on Tunnels, the first was in France, and the next one will be in Spain, in Granada, in next year in October. And don't forget that the next World Congress will be in Prague in October 23. Thank you very much. I don't know if we have any other, no, we have not anything, but just say you thanks a lot. Thanks a lot of thanks, many thanks for your contributions and for being here. And please keep in contact with us, giving your feedback, because it's very important for us. Thank you very much for your contribution.
Thank you, everyone. It was a great meeting. Thank you so much. Thank you, Oscar.